Right, so they are running two of the forges. So instead of walking over by those guys while they're working, I'm just gonna stop over here at this one. It's basically the same idea. This is an older setup though. And you can see it's got a nice fresh coat of paint, thanks to a couple of the guys the past few weeks have painted it. Made it look all pretty. There's also a whole bunch of wheels in front of shit, so getting in and out is gonna be kind of tricky. I'll try to get back here in this corner where the important parts are at. Let's see what I can see. It's a much larger setup than what the other machines are. They work virtually the same though. So the basic idea, I don't have a billet that I can show. Oh, maybe I do. Maybe there is one in here we can see. So what'll happen is, right here in this area, we'll load 2 skids of billets, which you'll see that in a second. That whole thing rotates 180 degrees. And it'll rotate the billets, which are those little semi-cylinder-like chunks of metal, which gets robot loaded onto that short little conveyor. And I can't really get back in there very well, but this is a preheat furnace, because we got to get those billets up super hot. Those little billets will cut through this thing. Like I said, this is an older machine, so it's a slightly different process for the newer ones, but the idea is the same. But they get preheated, the billets will preheat, and I forget the temperature that they go to. And they'll outfeed back there for this machine, which is where this robot right here grabs them up and then loads them into this giant son of a bitch right here. Yeah, it goes up there for a minute. But that is the forging press. Quite literally press. This is the 8,000 tons, if I'm not mistaken. 8,000 tons of pressure through the cylinders onto that small, round, 15-inch diameter, give or take, billet of aluminum that gets turned into these 22-inch round, almost wheels. There's a few other small processes involved here, but they're not overly interesting or important. But you can kind of see them as they come around. This is where some of the slug knockouts will be. So all the wheels have a hole in the middle. They literally get punched out by this cylinder. Whole other cylinder just for that job. They get knocked out, slugs fall to the ground, conveys up into that thing. Hot forgings will come around from being pressed out that conveyor and around, blah, 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 to the wash tank. Be cooled and rinsed, get all the excess oil off of them, cool them down to somewhat manageable hand temperature so you're not burning yourself to death every time you touch something, to get that product. Yay! Now it's a wheel. These guys are what that billet will sit inside of. So inside that giant press is a set of these dies, billet dies. And each one of them, depending on which one you're looking at, weighs somewhere between 10,000 and 30,000 pounds. So half of it, you can tell, are split in the middle. Half of it's attached to the upper portion of the cylinder, half of it's attached to the bottom portion of the cylinder. Wheel goes in between. And when the hydraulic press presses down, a shape comes out that is a wheel. I'm gonna walk back here on the backside to get another angle on the press. You can see the large cylinder in the middle, the 4 cylinders on the outside to help manage it. Awful lot of pressure for a very small thing. That's why you have to preheat it. You have to preheat the billet before you press it so it doesn't explode. That's kind of what these are back here for. These billets have not met spec for some reason or another. Whether they weren't hot enough when they came out, they were the wrong diameter, they were the wrong height perhaps. There's a lot of reasons why they could be, but they're scrap. Or Possibly not scrap once we get done remeasuring them. They might be able to be used for a different wheel set. But for the current wheel they're trying to run on this machine, when it runs, these billets won't work. So they send them out. They get tossed over into a dumpster, and we deal with them from there in some way, shape, or form. Whether it be send them back out and be recycled, put them over in a stack for a different wheel set, or whatever. Many things, many options. There's a lot more to the shop, but this being one of the forges, there's 2 more of these, slightly different setup. I won't really go into that. And like I said, they're working over there, so I'm not going to take a walk in that area and kind of be in their way. You can kind of see in the distance the upper portion of an old forge that doesn't work. That's going to go away here soon. I'm talking about tearing it out and doing something different. The machining process over where I'm at, majority of the time, is that's what I know more about. So I've got a little bit more I can speak on as far as that goes. It's not interesting in my opinion because I've done it for 8 years. In some way, I was part of the process for every wheel that's gone out of here, and we make about 1 million wheels a year-ish. I want to say more, maybe less. Numbers change. So, for the most part, that's a day. And I'm anywhere from one side of the shop to the other a dozen times a day, doing everything from oil change jobs to lube spill cleanups to polishing compound changes to coolant changes and checks, refraction ratings for the coolant. There's a lot of little stuff. And in between all that, I get the lovely job of riding around on a Zamboni. I clean the floors when I have time. Doesn't happen as often as they might want, but that's because I do about 25 million other things, and my radio is always going off to be called to another job for another reason, for some other silly thing that they want me to do. So that's it. That's a day.